Hello again, another Agakiller reaction. Today we will be watching What Would It Take for Everywhere Called Hell to Freeze Over from Simon Clark. I don't think I've ever seen anything from him, and I'm kind of curious if he's going to put the Polish hell. It's only one L, so I don't think I'm gonna be in it. I kind of seen you have the map in the thumbnail, so basically it wasn't there. So I was wondering if you're gonna mention it, but let's just jump into it. See where are the places called hell? I would like to know the history of it.
There are 4 places on Earth called hell. One in the Netherlands, one in Norway, one in Michigan, and one that we'll get to. And what would have to happen to the Earth's climate for all of them to freeze over simultaneously? And to be clear, I don't mean the temperature drops below zero at all these places. I mean they are covered in ice. We're talking Hoth-like conditions. Well, in the not too distant past, much of the Earth's northern hemisphere was covered in rivers of ice, glaciers in the ice ages, or more properly, the glacial periods of the ongoing Quaternary glaciation.
For the past 2.5 million years, the Earth has seen alternating periods of lots of ice and not much ice on its land masses. We call these glacial and interglacial periods, and we can see them super clearly in temperature records extracted from ice cores.
High temperatures correspond to interglacials, low temperatures correspond to glacial periods. We are currently, you can see, in an interglacial. There's only ice at the poles. And this is actually quite unusual. It's relatively rare in the recent past to be in an interglacial. In fact, at the start of the 20th century, some climate scientists were more worried about the return of the glaciers than any kind of global warming.
We can tell how far the glaciers reached by the geological features they left behind, markers like moraines, drumlins and eskers.
The glaciers reached their maximum extent between 26 and 20,000 years ago, and we can plot where they reached on a map. If we overlay the location of the towns called Hell, then we can see that they are all covered by ice at this glacial maximum. But what about that last place?
Where is the last place called Hell? Let's extend our map.
In tropics, okay. Yeah, that's well, I guess we would need to have a really low temperatures to actually go there and have that frozen over. But I'm guessing if it's with very bad drop of temperatures, maybe it's possible. Although, well, I guess we're gonna go into it. Oh, whoa, that's a long ad. Okay, I didn't even. It's one of those game ads. They're like 2 minutes long or something like that. So I'm just gonna say what I have to say, and then I'm just gonna cut and come back and finish that and come back. And anyway, so basically what I was saying. Oh, by the way, how do you like the lights? My mom put the battery back into it, so it's sparkling now. I used to have it in my old reactions for the trailer reactions, but I just didn't really bother to put them on. I don't know, we'll see. And so basically what I was saying about the freezing, I'm guessing it would have to go really low temperatures to reach that part there. So yeah, it would be rather hard to reach that, isn't it? Okay, so that's all I have to say. There's still a minute left of this one, and there's another one then after that. So I shall cut in here, and I'll see you in a second. Bye. Okay, so the next ad was another 2 minutes. So yeah, that was kind of like on the fun. So we were on the way, and he was showing that there's 3 places called Hell. And there's one in Denmark, one in Norway, and one in States or Canada. Actually, I really didn't pay attention to that. Anyway, it's in the northern hemisphere, and it's kind of like, you know, places that they probably get winters and stuff. So they would be covered, but the last one is in Grand Cayman Islands. There you go. So let's see.
Welcome to Hell, located on Grand Cayman, 19 degrees north in the Cayman Islands.
That's where the Grand Caymans are.
Gift shop. This hell did not freeze over at the last glacial maximum 20,000 years ago. In fact, it has never frozen over in the ongoing Quaternary glaciation.
The Quaternary glaciation is caused by small variations in the Earth's orbit around the Sun, changing how much energy arrives at the planet and where over tens or hundreds of thousands of years. When less energy arrives, the average temperature goes down and more ice forms. But clearly this isn't enough to freeze over hell in the Cayman Islands.
To make that happen, we need a different mechanism, something that we haven't seen for a very long time indeed. Let's have a look at the Earth's deep history. And also, before anyone gets smart in the comments, no, we can't just wait for continental drift to carry the Cayman Islands closer to the poles. We're trying to make the Earth freeze down to 19 degrees above the equator, okay?
The Earth's history is mind-bogglingly long. Approximately 4.5 billion years have passed since the planet formed.
Imagine walking in a straight line from the Space Needle in Seattle all the way to Miami in Florida, a distance of just under 4,500 kilometers. Each millimeter of that journey in real world corresponds to 1 year in the Earth's history. Every step you take, you go back centuries. Every meter.
I always have a problem with visualizing all that, because obviously this is a lot of time. 4.5 million years, it's a lot of time. So he have here a place that basically goes 4,500 kilometers, isn't it? And each millimeter is a year. Oh, Jesus.
A millennium, every kilometer you travel, you go back in time 1 million years.
Setting out from the Space Needle, the greatest extent of glaciers in the Quaternary occurred in the car park. The Quaternary glaciation began at Smith Tower, approximately also when humans first evolved. Some glaciation has been happening in Antarctica for nearly 34 million years, so roughly in the community of Hobart, while the dinosaurs lived from 65 to 250 kilometers down the road.
And the next period where the Earth had lots of ice was between 260 and 360 million years ago, so roughly near Moses Lake, the late Paleozoic ice house. Just like during our ongoing glaciation, it's believed that during this period the Earth went through glacial and interglacial periods for the same reason it currently is, wobbles in the Earth's orbit.
At times, the ice reached closer to the equator than it has recently. Most land at this point was actually in the southern hemisphere, in the supercontinent Gondwana, and some regions between 30 and 60 south were covered with ice.
That's maybe closer to the equator than recent glaciations, but not close enough to freeze the Cayman Islands, and so hell. For that, we need to go even further back in time, which poses a problem. The further you go from Seattle, the further back into the past, the less we are sure about anything. And in this huge expanse of time, bear in mind, we haven't even left the state yet, let alone crossed the Rockies, and we're already well before the time of the dinosaurs. There are 4 eras where we think the Earth had lots of ice. There may be more. Some people give different numbers.
The Hernantian, between 420 and 450 million years ago, we've finally left the state. The Cryogenian, between 635 and 720 million years ago, cutting into Montana. The Huronian, between 2.1 and 2.4 billion years ago, leaping over the Rockies into Kansas. And lastly, the Pongula, just under 3 billion years ago, somewhere in the middle of Arkansas, over 1 billion years before multicellular life.
This far back, there's not much to go on. We know that there was lots of ice on the planet at these times, but we don't know exactly how far the ice stretched or why exactly the planet was so much cooler. But we have theories. The best understood of these periods is, unsurprisingly, the most recent, the Hernantian, which we think is similar in extent to more recent glaciation. The oldest, the Pongula, is so far back that we really know very little about it. But these other 2 periods, they may have been different. They may have seen the entire planet covered in ice, both glaciers and sea ice, right the way down to the equator, with an average surface temperature as low as -50 degrees Celsius, a state we refer to as snowball Earth. Definitely cold enough to freeze over hell. We know of rocks showing signs of glaciation, both the physical scars left by glaciers and also the jumble of sediments they leave behind. And we know that these rocks formed near the equator. We know that through a technique called paleomagnetism, which looks at how certain crystals in rocks all point in the same direction, preserving the direction of the Earth's natural magnetic field where those rocks initially formed. Specifically, it tells us their latitude. So irrespective of where they ended up through continental drift, we know where they formed.
But scientists are unsure whether the whole planet froze, snowball Earth, or if there was a bit of surface ocean that remained liquid at the equator, what we call a slush ball Earth. It's unclear how a true snowball Earth would have thawed, and evidence from both modelling and observations indicate a slush ball was maybe more likely. It's an ongoing debate.
Okay, but snowball or slush ball, the planet basically froze. Let's assume that it included the area where the Cayman Islands currently are. The question is, why did that happen? Let me introduce you to the iceberg of possible explanations. At the top we have the version that basically everybody agrees on, but below the surface we get progressively wackier explanations for global glaciation events, all made possible by the fact that we just don't know very much for sure.
Let's start at the top with our good old friend.
I mean, I heard about the snowball Earth, but I haven't really heard about... Oh, where's my mouse? Here. About slushy Earth yet. Oh. I mean, it makes sense, doesn't it? So... Sorry, this is, what is it? HelloFresh ad. You can unbox the bags that they come in. They are numbered as well. Just perfectly proportioned food inside. Perfectly proportioned. It's depending on the person, you know. I think. Anyway, I'm digressing from the thing because, like I said, slushy Earth. I mean, probably both of the hypotheses would make sense. I'm not a scientist, so I'm not going to fight over one or the other. If they're saying that it's possible this way or it's possible that way, and they don't have enough proof to just basically prove the fact that it was either this way or that way. It's just okay, you're the scientist here, why not? So excuse me, that is looks nice. Okay, so I was a bit mumbling here now, so let's just go back to it and see what the explanation is.
It's carbon dioxide. CO2 has always been in the Earth's atmosphere, but its concentration has varied quite a lot, going maybe as low as 180 parts per million at times, and maybe as high as 4,000 parts per million at others. And those changes have caused huge changes in the planet's average temperature. Earlier this year, a paper was published that reconstructed the past 500 million years of the Earth's temperature, with one of the authors describing CO2 as the master dial for those past temperature changes. On geological timescales, CO2 gets added to the atmosphere through volcanic activity, and it gets removed through the weathering of rocks, what we call the carbonate-silicate cycle.
Carbon dioxide in the air dissolves into water when it falls as rain, making the rain slightly acidic. If that slightly acid rain falls onto rock, then a chemical reaction can occur which effectively locks the carbon into a new form, first on the surface and then getting flushed into the oceans where it's buried as new rock.
The amount of CO2 in the atmosphere at a given time then depends on geological timescales on volcanic activity on the one hand, and on the other hand, where weatherable rocks are in relationship to rainfall patterns. If through continental drift you end up with lots of land with lots of exposed rock, where there is lots of rain, like the tropics, then you start sucking lots of CO2 out of the atmosphere. CO2 concentration falls, the greenhouse effect weakens, and the average temperature of the planet falls. Then, when ice starts forming at the poles, the planet starts becoming more reflective. Ice reflects more sunlight than open ocean does, which is quite dark, and that means less energy coming in from the sun stays in the Earth system, which reduces temperatures even more. We call this ice albedo feedback. This is what we believe happened in each of these glaciation periods. Maybe a reduction in volcanic activity, but almost certainly an increase in weathering due to changes in rainfall patterns or changes in land masses. For example, in the Cryogenian, we think that was triggered by the breakup of a supercontinent called Rodinia, which massively increased rainfall, which increased weathering, and so increased the drawdown of CO2. If you're wondering, by the way, these glaciations end when volcanic activity ticks back up again, more CO2 is added to the atmosphere, and then the retreating ice caused by rising temperatures then kicks off the other aspect of ice albedo feedback, because as the ice retreats, it reveals more open ocean, which then absorbs more energy from the sun, which causes more warming. Thank God we're not seeing that today, eh? So, if you wanted to make hell freeze over, the vanilla way to do that would be to reduce CO2 concentrations in the atmosphere. Firstly, stop anthropogenic carbon emissions, then somehow suck loads of carbon out of the atmosphere. The old school way to do that would be to rearrange the continents such that you get lots of weathering of rocks where there's lots of rainfall. Maybe aim for 150 parts per million of CO2 in the atmosphere. That would probably do it. But as I say, that's quite vanilla. Could I maybe interest you in asteroids? This is something that may have contributed to the Henanshan glaciation. We think that a large asteroid impacted what is now Australia and left behind a 500-kilometer wide crater. For reference, that's about the size of Wyoming.
Just as happened with the asteroid that hit the Earth at the end of the Cretaceous period, killing off the non-avian dinosaurs, this would have sent immense amounts of dust into the atmosphere, blotting out the sun, reducing incoming radiation, and immediately cooling the planet by up to 8 degrees Celsius. Not a nuclear winter, but a cosmic winter.
If other factors were lined up, like this all happening when CO2 levels were comparatively low or volcanic activity was comparatively low, then that one-off event could be enough to tip the planet into a glaciated phase, with ice albedo feedback doing the rest. And that also applies to all the other wacky theories I'm about to go into. So sling a massive asteroid at the planet. That's an option, but you might not even need to hit the planet with that asteroid. Because what about a planetary ring?
Another possible explanation for the Henanshan freeze is
That's
the breakup
interesting.
of a large body in the asteroid belt, maybe 150 kilometers across, part of which fell into the Earth's gravity well. The Earth's gravity then tore that fragment apart, potentially giving the Earth a planetary ring for up to 40 million years.
The shadow cast by that ring on the planet may have reduced incoming radiation enough to significantly cool global temperatures. But what definitely would have done that is the ring gradually entering the Earth's atmosphere as it deorbits. That would have blotted out the sun through cosmic dust, effectively, and maybe would have been enough to tip the planet into a glaciated state. Of course, you could have the same effect by putting something more mundane into the atmosphere, like sulfur dioxide, titanium oxide, something reflective that would reduce the amount of sunlight coming in. Or if you wanted to be spicy, you could just build a giant mirror between us and the sun. You know, same end effect. But the wackiest way you could freeze the planet, freeze all the places called hell, something that we think may have actually happened in the past, is through gamma rays.
When a large star dies, it goes out with
Oh,
a bang,
yeah,
called
go-
a supernova. A colossal amount of energy gets released as short-wavelength radiation, what we call gamma rays. It's believed by many that this radiation doesn't get distributed equally, however. Much of it is concentrated into two opposing directions, determined by how the star was spinning before it died. Two jets of unimaginably intense radiation, like a cosmic sniper rifle, that would cause huge damage to anything living in its path. And it has been hypothesized that this happens to a star roughly near Earth, pointing directly at us.
The chances of this happening in an individual year are vanishingly small, but this is a huge expanse of time, and it is entirely possible that at some point in the past 4.5 billion years, one of these events did impact Earth. It has been hypothesized that it led to the Henanshan glaciation, but to be honest, it could have contributed to any of these periods, though not the Pongola, for reasons that will become immediately clear. The gamma rays probably wouldn't do much to the surface because we have the ozone layer. It would probably take the hit, though that depends on how strong the gamma ray burst was. But the high energy radiation would, break apart the diatomic oxygen and nitrogen molecules that make up most of the atmosphere, producing isolated atoms. Those atoms would then combine with whatever was nearby, most likely oxygen and nitrogen, producing nitrous oxides. And when that combines with water vapor, present everywhere in the atmosphere, you get nitric acid. That has a double whammy effect on temperatures. Firstly, the droplets of nitric acid would, suspended in the atmosphere, reflect sunlight, just as we see droplets of sulfuric acid reflect sunlight in the aftermath of large volcanic eruptions, cooling the planet directly.
But secondly, the nitric acid would eventually rain out and enter the ocean, where it would act as fertilizer for nitrate-limited photosynthesizers like phytoplankton.
That could, again, this is all hypothetical and dependent on how strong the gamma ray burst was, have led to global eutrophication, a global bloom in photosynthesizers that would immediately suck enormous quantities of carbon dioxide out of the atmosphere, which would then reduce the greenhouse effect, lower temperatures, and potentially tip the planet into a glaciated state. Did this happen? It's so far in the past, who knows? So there we go. If you want to freeze the 4 places on Earth called hell, yes, in the one in the Cayman Islands, then you've got some historically informed options.
Get CO2 levels really low. If you want to be old school, rearrange some continents. Throw an asteroid at us. Even if you miss, it doesn't really matter. Or, if you have a flair for the dramatic, just blow up a star.
It's funny. He's funny. But I have to give it to him. That video is actually really funny. So, yeah, like blow up the star. Just why not? Just to go and freeze the hell in Cayman Islands. Wait, that wasn't Cayman Island. Was it Cayman Islands? I already forgot what island was that. Terrible. My memory is so bad. Anyway, this ad is kinda quick, so I just can ramble. And yeah. Oh, another one. Oh, this is not quick. 3.5. Yay. Okay. So, I don't have much to add because, like I said, he was really funny and stuff. So basically what I'm gonna do, I'm gonna watch this, gonna rearrange stuff around in my computer while this is going, and I'll be back in a second. Okay, I'm back again, and we'll be just finishing up because honestly there's only like less than 2 minutes left in this video and we got the ad, so just jump into it and just see.
Would you like to blow up a star?
Yeah!
Boy howdy, do I have a sponsor for you. Because this video was made possible by Brilliant, who I'm just learning do not blow up stars.
Yeah.
But do give them the tools to let you do it yourself. That's because Brilliant is an educational website and app with thousands of interactive lessons on subjects in maths, programming, and data science.
Every supervillainous scheme has got to start with the fundamentals, and with Brilliant you can learn coding from the absolute ground up, or learn about maths from fundamental geometry to calculus. That star isn't going to know what hit it.
Crucially, this isn't one of those websites where you just read paragraph after paragraph of information and then parrot it back. You are involved in the learning process from the very beginning thanks to their interactive exercises, which are written by an award-winning team featuring people from Google, Caltech, MIT, lots of places.
And pretty much no matter what you're interested in within STEM, there is a course for you.
Think about the last person you spoke to who blew up a star. Do you think they spent lots of time on their phone doom scrolling? No, they had Brilliant installed as an app and built a daily learning habit, improving their problem.
He's very funny. I have to subscribe to him. Check out what else he had there.
If you go to brilliant.org/Simon Clark or scan the QR code on screen, then you can get full access to Brilliant for free for a full 30 days. And if you like what you find, you can also get 20% off an annual subscription, which, I should point out, also applies to buying access to Brilliant as a gift for somebody else, maybe the student in your life. To sort out that Christmas present, go to brilliant.org/Simon Clark. But thanks to Brilliant for, well, being brilliant. Massive thank you to my patrons for choosing this topic. Shout out to Thomas in particular. If you would like to become a patron of this channel and support me making bigger and better videos, then you can do so at the link in the description. You get early access to videos as a patron, as well as exclusive content, and at higher levels of support, you also get to vote on a video topic a month. If you enjoyed the video, please do the YouTube pleasantries, leave a like, a comment, that kind of thing. Here's 2 videos I made earlier if you'd like to watch something else from me. And I just want to say that there's one more video coming out this year in which I will recap all the climate news from this year. If you're not already subscribed, please do so you don't miss that. Thank you for watching, and I'll see you in the next one.
That was really good. What? Nope, those ads are just going straight up. They just assault you straight up. So yeah, that was really good. Slash Planet, definitely something I'll have to look up. Although I did watch something about Snow Globe Planet, Earth, Earth, I think it's called, isn't it? So basically, yeah. And I was talking on the ad break, so I don't really have much to add now because the last ad break was before the sponsors video. So like, yeah. And again, thank you very much for watching, and I see you tomorrow. Bye.